Hello everyone, my name is Griffith Hughes and I will be helping you solve question 6 from the 2008 AP Calculus AB FRQ. I have attached the link to this problem and the official solution in the description below, as well as some resources you might want to use for extra practice. This problem mainly covers topics from sections 1.6, 2.2, and 4.2 in our Calculus Early Transcendentals textbook, and is based mainly on our understanding of derivatives and their applications, as well as our knowledge of the natural log function. As we read through the problem, it is always important to highlight key words such as justify or phrases such as find the x-coordinate of this point. These key words will help you go through the FRQ question faster and keep you on topic while you are answering it. Let's begin with part A, which asks us to find the equation of the line tangent to the graph of f at x equals e squared. Since this problem asks us to find the equation, we know that we will need to find a y value at some point in order to plug into the point-slope form to get our final answer. Thus, we plug e squared into f and solve, getting 2 over e squared. So our point is now e squared, 2 over e squared. Now we must find the slope of the tangent line, so we use the derivative of f to find the slope at e squared, which gives us -1 over e to the 4th. Now, we can plug everything into point-slope form and get y minus 2 over e squared equals -1 over e to the 4th times x minus e squared. One important thing to note here is that you don't need to put your equations into y equals mx plus b form, since you are more likely to make mistakes and might use up valuable time. Part B asks us to first find the critical point of f, then to use this point to determine if it is a relative maximum, minimum, or neither. A key thing to notice here is that the problem says to justify your answer. As soon as we see justify, we know that we will need to write a sentence explaining our answer. Since the problem gives us the derivative of f, we must start by setting both the numerator and the denominator equal to 0. However, we notice that x is greater than 0, so we are able to rule out 0 as a critical number. Solving for the numerator, we find that the critical number is e. Now, we must test this number to determine if it is a relative max, min, or neither by determining the sign of the intervals. Since the sign of the interval from 0 to e is positive and the sign from e to infinity is negative, we know that x equals e is a relative max. Our justification for this is that the sign of the derivative of f changes from positive to negative at e, proving that x equals e is indeed a relative max. Part C asks us to determine the point of inflection of f and find its x value. To do this, we must find the second derivative of f. Remember, we're going to have to use the quotient rule, low d high minus high d low, square the bottom, and away we go. And then we'll set it equal to 0 to determine possible values. Again, we are able to cancel out 0 since x has to be greater than 0. We find that there is a critical number at x equals e to the 3/2 since the sign of the second derivative changes from negative to positive. It is always good to justify our answer just in case the graders are looking for something specific, so always mention the change in sign. Part D asks us to find the limit of f of x as x approaches 0 positive. Remember, that's like 0.00000000001. It's just above 0. And to do this, we substitute 0 positive into f of x, which gives us the natural log of 0 positive all over 0 positive. Since we know that the graph of natural log of x approaches 0 but never reaches it, we know that the natural log of 0 positive is negative infinity, because as the closer you get to the y-axis, it's going to just keep on going down, and that's why it's negative infinity. So once we divide by 0 positive, the number is still negative infinity since there is no way for it to get any larger. It's like infinity times infinity, which is still infinity. So another possible answer to the question is does not exist, but both are considered solutions by the College Board. In order to do well with problems like this one, you must be familiar with derivatives and you must know how to graph functions such as natural log of x. Also, you must be familiar with limits, and it may be useful to use L'Hopital's rule on other problems. I said it right, I think, Mr. Shea. Do I get a round of applause? On other problems, even though it is not required in Calc AB. Hospital. Haha. I have attached a link to a doc that has similar problems below from other AP tests, and you can look up their solutions by just typing in their name and the word solution after it, as I'm sure many of you guys have been doing on your homework. I hope this video helped explain it, and if you guys have any further questions, feel free to ask. Thanks.